Hello and welcome. In this video, we will be diving into one of the most crucial steps in machine learning progress, model evaluation. Whether you are building a classifier, a regressor, or any other type of model, accessing its performance is essential for success. Today, we will cover everything you need to know, from evaluation metrics to handling challenges like class imbalance. Let's get started. The first subtopic we'll be covering in this video is importance of model evaluation. First, let's talk about why model evaluation is important. Evaluation of our model help us identify their strengths and weaknesses, guiding us towards improvements that can boost performance. With this step, we won't be guessing how well your model work in real world scenarios. By thoroughly evaluation our models capabilities, we can make more informated decisions about when and how to deploy it. Model evaluation provides a framework for comparing different algorithms and selecting the best one of them for your task. And lastly, evaluation helps us to detect outfitting when a model performs well on training but struggles to generate a new data. Next up, we have supervised versus unsupervised learning evaluation approaches. They are the types of, you can say, types of evaluation approaches. In supervised learning, we evaluate model performance on test data using metrics like accuracy, precision, recall, F1 score, and ROC AUC for classification tasks. For regression, we look at metrics like R squared, RMSC, and MAE. For unsupervised learning, there things get a bit different. We often rely on the internal metrics like in area for clustering of reconstruction error for dimensional reduction, but we can also use external metrics to compare the model's result to ground truth data. Now we have the next subtopic is splitting data, trained, validation, and test sets. Now let's talk about how to split your data for model evaluation. The trained data train set is used to fit the model's parameter. It should be large and representative for your data. Then we have to validate sets, which help us to tune hyperparameters and access performance during training. It prevents outfitting by ensuring the model generalization well. Finally, the test set is crucial. It provides an unbiased evaluation of the model's performance after all the training and tuning are completed. Next up we have is evaluation metrics for classification models. For classification models, there are a few key metrics we use to evaluate performance. Accuracy. Accuracy tells us the proportion of correct prediction made. Precision. Precision measures the ratio of two positives to all predicted positives. Recall. Recall looks at the ratio of two positive to actual positives in the data. F1 score. And F1 score gives us a balance measure by combining precision and recall. Now we have the next subtopic is evaluation metrics for regression models. For regression tasks, we have different metrics to access model performance. R square. R square shows the proportion of variance in the target variable that our model can explain. RMSE. RMSE or RMSE. RMSE stands for root mean squared error. measures the average of the squared difference between predicted and actual values. MAE, finally, MAE or mean absolute error calculates the average of absolute difference between the predicted and true values. Next up, we have the dealing with unequal error cost. In many real world situations, not all errors are equal. Some mistakes can be more costly than others. So here we have to understand the context. First, you need to understand the specific cost associated with different errors in the problem to win. Second, we have adjust the loss functions. One solution is to adjust the loss functions to penalize more costly errors more heavily. Third one, we have optimize the thresholds. Another approach is to optimize the decision thresholds. For example, in classification, adjusting this threshold can be help balance precision and recall based on your needs. Next, we will be discussing handling class imbalance in model evaluation. Class imbalance is a common issue, especially when one class has significant more samples than the other. Here's how we can handle it. Sample over majority class. Oversampling the majority class by duplicate instance can help balance the data. Undersample majority class. Alternately, undersample majority class. Alternatively, you can undersample the majority class by removing instances. Use class weights. Many models allow you to assign higher weights to the minority class due to training, improving model performance for that class. Evaluation with appropriate metrics. Make sure your evaluation with metrics like precision, recall, and F1 score rather than accuracy to account for the imbalance. Next, we have cross-validation techniques. Cross-validation is a great technique to ensure our model performs well across different subsets of data. First in we have holdout validation. Holdout validation splits data into fixed training and test sets, but it's limited because it does not use all of the data for both training and testing. K-fold validation. K-fold cross-validation divides the data into k-folds using k-1 for training and 1 for testing, repeating this k times for more reliable result. Satisfied k-fold. Satisfied k-fold ensures each fold maintains the same class distribution as the entire data set, which is especially useful for imbalancing datasets. Next in we have model selection and hyperparameter tuning. Once you have evaluated multiple models, you want to choose the best one. This involves tuning the hyperparameters, setting your choose before training the model. In this, we have the first grid search. Grid search systematically tests a wide range of hyperparameters combination. Second, we have random search. Random search samples hyperparameters randomly, often providing faster results. Next, we have Bayesian optimization. Bayesian optimization tries to find the best hyperparameters more efficient by learning from the past results. Validations. Remember, use the validation set to guide hyperparameters tuning and pick the model that performs best. To wrap up model evaluation is a key part of building successful machine learning models. By using the right metrics, dealing with challenges like class imbalance, and fine tuning hyperparameters, you can ensure your model is ready to deploy. Thanks for watching, and don't forget to subscribe, and hit the bell icon for more machine learning tips and tutorials. See you next time. Keep learning.